Welcome to today's class. Yesterday, if you had a little doubts of what was done, I'll brief that up and we will go on to the next class of today. So we were seeing about what is electric lines of force, what is electric field lines, and we were seeing the diagrams of what was related to it. So what is electric field is a region surrounding any electric charge. We call it as your electric field. And imaginary lines drawn for it, you call it as the electric field lines. So we did with a few diagrams for a positive charge, that is if Q is greater than 0. Look at the lines of force. It was directed outwards. The lines should go in the outward direction for a positive charge. The same thing if it's going to be a negative charge. For a negative charge, the charges will be directed in the inward direction. This is where we were doing yesterday. So positive means arrow mark should be outwards. Negative means arrow mark should be inwards. So this diagram we saw, and after this, arrow marks denote the strength. You can see the second diagram, only one arrow mark is there. Here you can see there are many number of arrow marks. Here the strength is less. Here the strength is going to be more. The same thing you can observe even for a negative charge. What to keep in mind is positive, or if the charge is greater than 0, the arrow mark should be outwards. If it's a negative charge and if it is less than 0, arrow mark should be inwards. So that is what you have to make a note. So yesterday's question was answered correctly first by Swati. Congratulations, Swati. But she gave only one correct answer in the beginning. So in the order, questions answered by Savina. She gets the first place. Steffi Margaret gets the second. And I'm very happy other students are also involved. Mugambika gets the third. So congratulations, Savina, Steffi, and Mugambika. Swati, congratulations. Immediately after that, she also gave the 2 answers. And others are also answered. Only the first 3 I'm mentioning. So congratulations, girls. Very good on your answering of your questions. So today we will just see what is an electric dipole. Dipole, I told you, 2 equal and unlike charges. Equal means magnitude should be the same, Q and Q. When I talk about unlike, charge should be different. One should be positive, the other one should be negative. So 2 equal and unlike charges, we call them as a dipole. How to draw electric field lines for that? I told you for a positive, it should be outwards, and for a negative, it should be inwards. So you can see clearly. The arrow mark here is denoted outside, and the arrow mark here is denoted towards your inner side. So if you take a positive charge, the lines should always be towards your outward direction. And if you take your negative sign, it has to flow towards the inward direction. And if you take the next example, electric lines of force due to pair of equal and like charges. Here we saw it is equal and unlike charges. So if they are like, meaning both should be positive and positive. How does these electric field lines appear? So here you see this is also plus Q. Here also you have plus Q. So this is an example for equal and like charges. For both, arrow mark should be outwards because both are positive. Here it's like a loop, like a curved line. Whereas here you can see it is diverging away. So this diagram of electric field lines is a 2-mark question. If they tell you equal and unlike charges, this is the way you should draw it. If it is equal and like charges, they have to repel from each other. And you can see you can draw your X and Y axis to represent they are moving away. And you can draw a spherical line. The sphere here in both the lines indicate the electric field. So till where electric field will act is denoted by that symbol. Today's class, we will see about I just want you to tell something. The class is at 10:30. So if you are on time, it will be better. We will allow you even till 10:35, 10:40. After that, when you are joining, no, it's creating disturbance. So see that you are on time at 10:30, 5 to 10 minutes connectivity problem, I understand, but later than that will not be fine. So be that you are to the class on time. And I think you have a book and pen with you in your hand. Apart from what is there in the slides, please make it a note to note down the points. Today's assignment will not be from what I'm sharing. It will be only from the questions of what I'm telling orally. So anything I'm telling extra, please make a point that you write it down. Yesterday's class, when we were talking about, I was telling you we have two types of charges. One is the source charge. The other one is called as your test charge. So what is the source charge or what is this test charges? Please have a pen and a paper and make a note. Source charge is a charge which produces the electric field. What do you mean by source? It has to produce something. So source charge means it has to produce an electric field. I'm repeating it. Source charge produces electric field. Source means what? Something which is producing. So what is a source charge? A charge which produces electric field, we call it as a source charge. Second point, I told you test charge. In last class, I told you clearly, test charge should not create any difference due to its presence. So that is called as a test charge. I'm repeating it. Test charge is a charge having very small magnitude. It is having very small magnitude so that its presence should not affect the electric field. So it should have very small magnitude and its presence should not affect the electric field. So these two questions I want you to keep in mind. One is source charge, which produces your electric field. Test charge, which has small magnitude and its presence should not affect your electric field. Now, having come knowing all these two things, we will see what are the properties of electric charges. So the first property of electric charges, it is additive in property. What do you mean by additive? You can add the charges. If there are 4 or 5 charges what you need, the charges can be added. See, it's clearly given. Q equals Q1 plus Q2 plus Q3 plus so on. How many ever charges are there? We can add up your charges. So charges are additive. First point. Second point, charges are quantized. What is quantization? Any charge can be expressed as an integral multiple of E. E is charge of an electron, 1.6 into 10 to the power of minus 19 coulomb. So if I have 5 charges, the total charge will be equal to 5 into 1.6 into 10 to the power of minus 19 coulomb. So what is quantization means? Any charge can be expressed as an integral multiple of E. Integral multiple means it should be multiplied by n. So first point, charges are additive. Second point, charges are quantized. And the third point is charges are conserved. What is conservation? Charges can neither be created nor destroyed. You can convert it from one form to another. We also have the law of conservation of energy. Energy can neither be created nor destroyed. So here 3 properties. To just keep it in mind, A, Q and C. A is for additive, Q is for quantized, C is for conserved. Just tell it in your mind and check once. A is for additive, Q is for quantized and C is for conserved. Very important 2-mark question. What are the properties of electric charges? You should blindly tell charges are additive, point number 1. Charges are quantized, point number 2. Charges are conserved, point number 3. So having known this, we'll move on to our second question. So your second question is, state and explain Coulomb's law of electrostatics, or it is also called as inverse square law. So what is this inverse square law or Coulomb's law is? Observe carefully. Statement of the law. Force of attraction or repulsion between 2-point stationary charges. So here the force of attraction or repulsion between any 2-point stationary charges should be directly proportional to the product of the magnitude of charges, and it has to be inversely proportional to the square of the distance between them. So that is the statement of Coulomb's law. I'm repeating it. Force of attraction or repulsion. Learn that as your first point. Between 2-point stationary charges. That's your second point. Third point, it should be directly proportional to product of magnitude. Fourth point, it should be inversely proportional to the square of the distance between them. So these are the statement of the law. We divide the definition into four. First part, force of attraction or repulsion. Second part, between 2-point stationary charges. Third point, is directly proportional to the product of the magnitude. Fourth point, inversely proportional to the square of the distance between them. In your mind, quickly learn of the definition. If you consider two charges, Q1 and Q2, and they are separated by a distance of D. So F should be directly proportional to product Q1 and Q2, and it should be inversely proportional to the square of the distance. What is the distance here? It is D. Square of the distance means D square. Because it is inversely proportional, I'm writing it down in the denominator. So this is your mathematical form. F is proportional to Q1, Q2 divided by D square. Proportionality sign, if you have to remove and introduce the constant, we write the value to be K. K is my proportionality constant. So F will be equal to K into Q1, Q2 divided by D square. K value is 1 divided by 4 pi epsilon naught. Please note, value for 1 by 4 pi epsilon naught is 9 into 10 to the power of 9. It is constant. So here K is your proportionality constant and its value is equal to 1 divided by 4 pi epsilon naught. This is your mathematical form of Coulomb's law. F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. The same thing if you have to write it in vector form. I'm going to express it as F12. That is two forces we are having, Q1 and Q2. So we write it as F12. The same formula. F is equal to 1 divided by 4 pi epsilon naught Q1 Q2 divided by D square. What is remaining is your unit vector, that is R cap. Here if you write 1, 2, in R cap you should write it as 2 and 1. That's the difference. R12 means, F12 means here you will write it as R21. Its value is 1, so you need not worry about anything. F12 will be equal to 1 by 4 pi epsilon naught Q1 Q2 divided by D square into R21. R12 will be equal to minus of R21. What does that mean? Force because of the first charge on the second charge will be equal and opposite to the force of the second charge because of the first charge. Here you have to consider Newton's third law. I want somebody to tell me Newton's third law. Hussefa? Newton's third law? Newton's third law. For every action?
Every action there is an equal and opposite reaction.
Every action there is equal and opposite reaction. Very good. So that is a statement for Newton's third law. For every action there is equal and opposite reaction. Considering that,
opposite reaction.
very good. So we'll consider that. So first force will be equal to minus of the second force. If you're using Newton's third law, and here you will get that answer. F12 is equal to minus of F21. So Coulomb's law is the second important question. Force of attraction should be directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Vector form, same formula. Here just write 1, 2, put an arrow mark on top. R you write 2, 1, put a cap on top. That is how you represent it. So going to our next part, we will be deriving an expression for electric field at a point on the axis of a dipole. Now, what is dipole? I already told you, two equal and opposite charges, or two equal and unlike charges separated by a small distance. We call it as a dipole. Now, you can see here clearly this is plus q and this is minus q. So, they are equal and opposite. Distance of separation should be equal to 2a. This is the general condition for a dipole. The charges should be separated by 2a. Since O is the middle point, 2a can be split into a and a. That is what is there in your diagram. Minus q here, plus q here, middle point label it as O. Total distance between plus q and minus q will be 2a. Individually, I'll write it as a and a. And one more point P we are considering, which is at a distance small r from the center of the dipole. Keep it clear. P is a point at a distance small r from the center of your dipole. So this is your diagram. Since we are drawing it in a horizontal line, I call this as axis. We have two derivations for 5 marks here. Expression for electric field at a point on axis is first derivation, on equatorial line is the second derivation. So today we are doing for at a point on the axis of a dipole. I think diagram is clear for you. Minus q plus q. Center point is O. A and A. From O, mark a point P, which is at a distance R. So to start our derivation, let P be a point on the axis of a dipole of moment P vector. So moment is a product of your force and the perpendicular distance. Moment will always be denoted by the symbol P. So P is a point on the axis of a dipole of moment P vector. Its length should be equal to 2a. Wherever you come across dipole, distance of separation will normally be equal to 2a. And it should be at a distance r from the middle point. So you draw your diagram, you write this point. P should be a point on the axis, length should be 2a, and distance should be r. Observe carefully. Electric field at the point due to the positive charge. What charge is here? It is due to the positive charge. Formula is Coulomb's law. 1 divided by 4 pi epsilon naught Q1 Q2 divided by R square. Here we are considering only positive charge. So you write it as Q. Observe carefully. If it is positive charge, your distance will be R minus A the whole square. Okay. R is the distance from here to here. A is this distance. So if you want for the positive charge, it will be this R minus of A the whole square. Same thing, electric field at P due to the negative charge. Observe, here it is negative. That is E2 will be equal to 1 divided by 4 pi epsilon naught Q divided by, here it is negative means here you will get a plus sign. It is R plus A the whole square. Why we are getting plus? Charge Q is here. So from P to O it is R. From O to Q it is A. So if I want for this, I should add the total length. That is R plus A the whole square. And direction should be mentioned. First one will be along OP from here to here. Second one will be along PO. Newton's third law again. Charges should be equal and opposite. So these two formulas you should write it clearly. I'm repeating it. E1 is 1 by 4 pi epsilon naught Q divided by R minus A the whole square for positive. E2 is equal to 1 divided by 4 pi epsilon naught Q divided by R plus A the whole square for a negative charge. Now we'll take the total electric field at P due to the dipole. Due to your dipole, your formula will be EA is equal to E1 minus of E2. So EA is what is common in these two terms. If you see, it is 1 divided by 4 pi epsilon naught. Take that outside. What is also common here? Q. So that is also removed. Remaining in A1, E1 is 1 divided by R minus A the whole square. Put a negative sign. Here it is 1 divided by R plus A the whole square. Write it down separately. See, we are removing out 1 divided by 4 pi epsilon naught into Q. Remaining in E1 is 1 divided by R minus A the whole square. Remaining in E2 is 1 divided by R plus A the whole square. Take it out, common. Now what you should do is take LCM here. I want Divya Darshini to answer what is A plus B into A minus B. Divya Darshini, Kirtana, A plus B into A minus B.
A square minus B square.
Vishalakshi, it's a simple identity. A plus B into A minus B.
A square minus A square minus B square.
A square minus B square. Very good, Vishalakshi.
B square.
Okay. We will use that formula now. A plus B into A minus B, you see, it is A square minus B square. A plus B here is R plus A. A minus B is R minus A. A square minus B square means you will get R square minus A square. Since we have one square on top, this will be written as the whole square. Keep it clear. We are using the formula A plus B into A minus B. That will be equal to A square minus B square. The square which is on top, you write it as it is. You can cross multiply here. We will write it as R plus A the whole square minus R minus A the whole square. Anita, what is A plus B the whole square? Anita, A plus B the whole square. Arshia, what is A plus B?
A square plus 2AB plus B square.
A square plus 2AB plus B square. Can you apply it
B
here?
square.
B square.
Okay, apply it for the formula R plus A the whole square. How will we write it as? R square plus A square plus 2AR. Very good. Then put a negative sign. Here you will write it as R square plus A square minus 2AR in formula for R minus A the whole square. Very good, Anita. So you're going to use that formula here and write it as R square plus A square plus 2AR. See, this A and D is interchanged here. When you're writing the answer, just mention it as A itself. So this will be, I'm using it for R plus A the whole square. So it is R square plus A square plus 2AR. Now when we take A minus B the whole square, we have a negative sign here. So it will be minus A square minus R square plus 2AR. Whatever is cancelling, just cancel it out. A square and R square will get cancelled. We will get 2AR plus 2AR, which is equal to 4A into R. So this will be EA is equal to 1 divided by 4 pi epsilon naught Q as it is. Add up these two terms, you will get 4AR divided by R square minus A square the whole square. Now here you have to make one small change. 4AR can be split into 2 into 2AR, correct? 2 2s will give you 4. So 4AR can be split and written as 2A into 2R. So when you do that, this Q into 2A will be replaced by the symbol P. P is called as your dipole moment. So 2A into Q will become P. Check what will happen to this formula. 1 by 4 pi epsilon naught. This term will become P into 2R divided by R square minus A square the whole square. So this is your expression needed for the dipole moment. So what you have to write is this formula. EA is equal to 1 divided by 4 pi epsilon naught 2 PR divided by r square minus a square the whole square. Here take LCM. A plus b, a minus b the whole square, you'll get a square minus b square. There's no need to show this step. Directly, if you simplify numerator, you will get q into 4ar. That is, you will add this. This 4ar will be split into 2a into 2r. 2a into q will give you your dipole moment p. So this will become 2pr divided by r square minus a square the whole square. If you neglect a square term, then EA will be 1 by 4 pi epsilon naught 2pr divided by r to the power of 4. How you're getting that is r square the whole square will give you r to the power of 4. A square is neglected because we are going to consider a to be very less than the distance. Then 2pr divided by r to the power of 4. You can cancel r and r to the power of 4. So we will get 1 divided by 4 pi epsilon naught 2p divided by r cube. So this can be the final expression. You can stop it here. One more point you can add. If a is very less than b, a square gets neglected. So our expression becomes 1 divided by 4 pi epsilon naught into 2p divided by r cube. When I share the notes, please write this white paper thing into your notebook. I will show you the next slide for your understanding, but I want you to write the notes which are there in the white paper. Please don't confuse. Same derivation. I'm showing it to you in the form of a slide. The same derivation what we did now. So electric field intensity due to a electric dipole. You're considering minus q here and plus q. We are just brushing the terms. Your notes, you will write what is there in the paper. This is just for your understanding. So you're considering two charges, minus q and plus q. P is your dipole moment. Consider 2 points A and B. Middle of that is denoted as O, and that distance here we are taking it to be equal to L. In the previous thing, I wrote this to be equal to A. And from O to P, your distance will be taken as X here, because some textbooks denote with X, some textbooks denote it with R. So I'm doing the both here. From O to P, your distance will be taken as X. In this case, in the previous derivation, it was taken as R. So keep that in mind. Now to do the steps, resultant electric field intensity at the point P will be EP is equal to EA plus EB. I wrote it as E1 plus E2. For simpler understanding, it is EA plus EB. So vectors are collinear and opposite. Collinear means they are in a straight line and they are opposite in direction. Hence, your total potential will be EB minus of EA. Previous derivation it was E1 minus of E2. So you can write the formula. EA is 1 divided by 4 pi epsilon naught Q divided by, here it is X plus R the whole square in my previous thing. Since I've taken it as L here, we are writing it as X plus L the whole square. EB will be 1 by 4 pi epsilon naught Q divided by X minus L the whole square. This is for the positive charge and this is for your negative charge. Total potential, you can take 1 by 4 pi epsilon naught Q divided by X minus L the whole square minus Q divided by X plus L the whole square. Q is common, which can be taken outside. If you're taking LCM, it is X square. Anita told us clearly. X square minus L square the whole square. Numerator will become 2 into L into R multiplied by 2. That is 4LR. Or in your previous thing, it was 4A into R. Split it into 2Q into 2L. So this dipole moment will be substituted now. P is your dipole moment, which is equal to Q into 2L. So this will be replaced by P. Your final expression is 1 by 4 pi epsilon naught 2px x square minus L square the whole square. If L is greater than X, then L square term will be neglected and we will get E is equal to 2p divided by 4 pi epsilon naught into x cube. Whichever is easier for you. You want to follow these steps or the previous steps, you do it for learning. But in your notes when you write, do it systematically. I prefer you writing the notes which are in white. And diagram should be clear. Here if the distance is a, this L term will become a. Here distance is x. So x term in your previous thing will become r. So you can either do this derivation or you can take up the previous derivation which is given for you. So whatever diagram we draw, a here, in the next slide we have taken it as L, and this distance will be taken as x in your next derivation. The remaining are same. But since for learning it should be with the sentences, I want you to write it. So this is the electric field intensity due to your electric dipole. How you to remember the steps is, first step, just remember for positive charge, it should be x minus L the whole square. For negative charge, it should be x plus L the whole square. Then we are subtracting. When you're subtracting, you should take the LCM. That will be x square minus L square the whole square. Numerator, it will be equal to 4AR, or here it is 4A into L. Next step, P is equal to 2A into Q. That should be substituted. Then you get your final expression. After doing that, if the distance is very small, you're neglecting the last term. Then you will get 2P into x divided by x to the power of 4. X and x will cancel. We will get x to the power of 3. So this is one example